2021, here we go, number 3. This one will make you cry if you're not careful. A student came up to me after this exam and said, never gonna play with toys again. Let's read. Company designs spinning toys, basically like a top, this thing that spins, using the family of functions y equals cx squared of 4 minus x squared, where c is a positive constant. C, notice where it is, that's going to be a scalar. That's not going to change the x-intercept, which is good to know. That'll come in handy in a few minutes. It is going to affect the magnitude of this loop, the vertical stretch. The figure above shows the region in the first quadrant bounded by the x-axis and the graph of this for some c. Each spinning toy is in the shape of a solid, okay, two-dimensional, but this is a solid, and it's generated when a region, such a region as this, is revolved around the x-axis, which kind of makes sense with the shape. If you take this and you revolve it around the x-axis, you're going to have this thing that could stand up and spin for a little while. X and y are measured in inches. Find the area of the region in the first quadrant bounded by the x-axis and the graph of this function, and they gave us the c value. So let's jump right in. If we are going to find the area of a region, let's use an integral. So here goes. 2021, number 3, part A, the integral from somewhere to somewhere. Let's go ahead and find out those somewheres. I'd like to think that one's really obvious. That one clearly is not as obvious. So we're gonna just sort of doodle over here. You don't have to draw this. It's not part of the grading or the scoring, but I'm just drawing, so I'll have something to go on. That is not a good representation. It should be looped a little more in this direction, but that's okay. Y equals cx square root of 4 minus x squared. I'm looking to see what the x-intercepts are, and again, that one is really obvious, but here's why. 0 equals all this stuff, x-intercepts, y is equal to 0. So I'm gonna put a 0 there, and so 0 equals this factor, and 0 equals this factor. So x is 0, and solve all this stuff, x equals 2. So it really doesn't matter what c is, you're still gonna have an x-intercept at 0 and at 2, which tells me this. Okay, well, let's keep going with this idea. We're gonna have the integral of that function, which is that function as well, and cx, all that stuff, but c equals 6. So let's do 6x squared of 4 minus x squared dx. I would like to think that you notice the type of integration technique we're going to have to use. This is an inner function whose derivative shows up elsewhere if you multiply by a certain factor. So the derivative of this would be negative 2x. That is negative 2x if you multiply strategically. So this is going to be u substitution, so let's go with that. U is the inner function. This is going to be in my way, so let's just block it off. The derivative of that is negative 2x dx. I don't want negative 2x dx. I need a 6x. So we'll make it. Whoops, that's not a 6. You can see where this is going though. I need a 6x dx. How do you turn a negative 2 into a 6? You negative triple it. Okay. So that means that we are going to be dealing with the integral from not 0 to 2. Okay, whoa, things are about to change. This is a definite integral using u substitution. So I have changed the inner part. Let's just go ahead and put that. There's a little bit more we'll put with it. But in order to change the stuff on the inside, I need to change what I'm dealing with in terms of my boundaries. So 0 goes here, 4 minus 0 squared, 4. 4 minus 2 squared, 0. Feel free to turn this over and change the sign. We're not done here yet though, because 6x dx is negative 3 du, so negative 3 du. So if you wanted to, you could say, well, you know what, why don't we just turn this around, put it in order, put the 3 square root of u du. Like, that's totally valid, you can do that. And all that happened was we just changed the sign and reversed this order. It kind of made it look a little neater. Not required, just kind of neat. Works out the same either way. So one more step just to help us process what's really going on. Let's use the correct number here. And that's going to be 3u to the 1/2 du. We're ready to take an antiderivative. We're going to add 1 to that exponent. And then 3 divided by 3/2. 3 divided by 3/2. Remember, this is calculator inactive. It's going to give me 2. So I have 2. There we go. Have 2 what? There we go. So we're going to plug in a 4, figure it out. Plug in a 0. That's pointless, but figure that out, I guess. 2 times 4 to the 3/2. And then minus 0. So let's not even put that. And you would not lose points for that. So the square root of 4 is 2. 2 to the 3rd is 8. That's going to give me 16. And they're asking for the area, so this is 16 square inches. Looking at the scoring rubric, I'm going to go ahead and show you how this one was scored, and you have access to the scoring rubric. You just Google it if you need to. You would get 1 point for this. That's it, 1 point for that. You're going to get a point for the antiderivative as well, and for the answer. Let me make sure I've answered this. Yeah, there we go. The antiderivative, and I want to make sure that this is really, I'm looking for, yeah, there we go. Now, there might be separate components of this that they would look for, and they might give you credit for pieces here and there. The scoring rubric goes into a lot more detail, but credit for this, credit for this, credit for this. Okay, bits and pieces in other areas. All right, now things get fun. And when I first read this, I had to really stop and think and make sure I understood what was going on. So I really recommend that you, if you have not done this one yet, pause it, try part B, and then come back to it, because I'm going to jump in like you've read it and you've thought about it, okay? So please pause this if necessary. Here goes. Part B. It is known that for this function, you already know that. Now, they're not telling you that c equals 6, all right? So let's just kind of ditch that. That was part A. The derivative is this. Okay, sometimes, not this one, but sometimes they'll say, demonstrate that the derivative of this is this. That would be something fun we could do, not now, because they told it to you. For a particular spinning toy, a top, they didn't call it that, but that's what it is, the radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of C for this spinning toy? Whoa, what? Okay. The radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of C? The radius of the largest cross-sectional circular slice. So here's what's really happening, and you get no points for drawing this, and it would be a waste of time if you did, but just for the sake of explanation, let's draw the axes again. And I'm going to draw the shape, hopefully a little better this time. There's that. But then if you were to, that's not perfect, but it's a little bit better. If you were to rotate this, and I'm going to switch colors one more time. If you were to rotate this, it would make this shape right here, which is this circular kind of thing. And if turn, there we go, it spins. There we go, there's your top. So switching colors one more time. Let's go red. No, that's what I use for the scoring guidelines. The largest cross-sectional circular slice radius is 1.2 inches. Okay, that, just to get a visual for it, it looks like a beehive, but that's what it is right here. So what is the value of C for this spinning toy? Okay, I'm going to give you some context clues. The largest means the maximum, so therefore the derivative is equal to 0. So we're going to just go ahead and take that idea and run with it. So how are we going to do everything? Sometimes just take a piece and run with it. So here's the deal. Largest is a maximum. That's where the derivative equals 0. We need to know C. You probably can't find C until you find some other stuff, like the X value that would give you that C. So let's do this. What I want to do is set my derivative that they gave me, and I don't have to find, equal to 0. So here we go. 4 minus 2x squared over square root of 4 minus x squared, and that is equal to 0. And we're going to solve, preferably for C if we can, but I'll go ahead and tell you that's really going to get you nowhere. So we're going to go ahead and take this idea, work with it a little bit here, and so cross multiply this thing, and you're going to end up with C, and then 4 minus 2x squared equals 0. And if you wanted to divide by C, you could, but when I worked it out myself, I distributed the C. I hear laughter in the hall. Someone's having way too much fun. Apparently they're doing calculus. 4C equals 2CX squared. And you can divide by C at this point. You could have done it from the very beginning. Again, I did not. Divide by 2C, you get 2 equals x squared. So x equals square root of 2. Let's not do the plus or minus thing. We're dealing with distance here. Okay, here's what happens. Here's what we're dealing with. We don't know the value of C for the spring, for the spinning toy. It's not a spring. I don't know where I got spring from. We don't know the value of C, but we do know that the X value that would give us that largest cross-sectional circular slice of 1.2 is this. Okay, what does that mean? Well, here's what it means. It means you make some awkward doodles on your paper just to separate your work. You don't have to do that. That's just my little system. The function itself is c times x times the square root of 4 minus x squared. And this is equal to 1.2 at x equals square root of 2. So I'm going to take this idea and solve it for c in this little itty bitty space I have here. So c times the square root of 2 times the square root of 4 minus the square root of 2 squared, and that better be equal to 1.2. And we're just going to keep going with this. So we're going to have c times the square root of 2, and this is, let's see, 4 minus 2, so that's the square root of 2, and that's equal to 1.2. So that's square root of 2 times square root of 2, so 2c equals 1.2. c equals 0.6. That's it. We found it. They wanted to know c, we found it. And the difficulty was the burying of the language. Largest, that's a maximum. Derivative equals a maximum where the derivative equals 0, or doesn't exist, but that wasn't a situation in this case. All right, let's score this thing, see what we got. This one was worth 2 points. Part B was just worth 2 points. And we got a point by setting the derivative equal to 0. And we did not get a point for this, but it was necessary to move on to this, and got a point for that. So 2 points right there. All right, let's move on. Part C. This one took me a whole piece of paper. Lucky me. For another spinning toy, another one, why do we have several? Because C could be anything, right? C could be any integer that you want it to, anything, practically. Let's not use imaginary numbers there. For another spinning toy, the volume is 2 pi cubic inches. What is the value of C for this spinning toy? Whoa, all right, here goes. It's about to get crazy. And here it is. Part C, volume. The volume of a rotation is pi times beginning to end, and we're going to take that whole function and square it. Okay, so here's the deal. It's essentially the accumulation of a lot of areas of circles. So radius, 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 because all these radii spin around. So pi times the radius squared, we're going to call it dx right there. And the function itself goes here. We don't know what c is because that's what they're asking. So cx square root of 4 minus x squared and then dx. But they did tell us this is equal to 2 pi. Lucky us. Okay, let's start solving. Let's go for the obvious first. That obvious would be that the pi's are going to cancel. That's going to become very convenient. While we're at it, let's go ahead and square a whole bunch of stuff. So we're going to have the integral from 0 to 2 of c squared, x squared, and then all this stuff was square rooted and it got squared, so 4 minus x squared. And then dx equals 2, not 2 pi. We've canceled the pi's out. All right. We can do a little bit of distribution if you're like, oh, there's an inner function and an outer function. No, you just distribute. Trust me. Trust me, trust me, trust me. It'll be much easier if you do. 0 to 2. 4c squared x squared minus c squared x to the 4th, all that dx. Let's parenthesize on the left as well. It's equal to 2. And we'll just keep going with this thing. We're going to take the antiderivative of this, add 1 to that exponent, old coefficient, which includes c, divided by new exponent, so 4/3 c squared minus, all right, add 1 to that exponent. Old coefficient divided by new exponent, so 1/5 c squared x to the 5th. That's going to equal 2. Let's go from 0 to 2, and I'm just going to keep going with it. We'll set it equal to 2 in a minute. Instead of being like equals 2, equals 2, equals 2. Just keep driving this train, all right? So we're going to plug in a 2, crank it out, plug in a 0. That's irrelevant. And that's going to give me 4/3 c squared times 2 cubed minus 1/5 c squared times 2 to the 5th. Again, this is calculator inactive, so we're going to have to beat this thing up. It's going to equal to 2 in just a few minutes, so it equals 2 now. We just haven't written that down again yet. So 8 times 4 is 32 over 3 c squared. And this one's going to be nasty, I'm warning you. This is 32 over 5, so minus 32 over 5 c squared. And I'm going to just factor out a c squared. And I have 32 over 3 minus 32 over 5, and that's equal to 2. And we're going to solve it for c. And we're pretty much ready to go at this point. Now, if you're like, let's get a common denominator, go for it. Have fun. I don't find it necessary, and there's a lot of room for error in there. So just keep doing as much as you can without getting too crazy with your math. 2 over 5. And so c equals this. By the way, this is not what the scoring guideline says it is, but it is correct and you will get credit for it. The scoring guideline goes a little bit further. They actually simplified this complex fraction, and I'm perfectly fine with it staying right here exactly the way it is. But they have an answer of the square root of 15 over 32, and I do want to show you where that comes from. So I'm actually glancing at mine, making sure I haven't accidentally lied to you somewhere. I think we're good, yeah, we're good. So before I do anything else, let me score this one, show you what they were looking for. 4 points on this guy. The general form of the integrand, which means they were looking for this right there. They were looking for that. I would probably, nope. That's one thing. And then that's another point right there. And the antiderivative of this was worth a point. And then the final answer was worth a point. Now, at this point, I am going to keep going. So let's simplify. And just a little trick you can do. This is a complex fraction. It's like 2 over 1, and then 2 over 1, and then 32 over 3, and 32 over 5. You have a common denominator among your 3, including this 1 here, your 3 denominators of 15. So if you multiply everything by 15, it's going to wipe out all the denominators that need to be wiped out. So let's see, I'll keep going. By the way, the whole thing is square rooted. Let's not lose sight of that. So 2 times 15 is going to give me 30. And then we're going to have 3 cancels with the 15, 5. So 32 times 5 minus, and then this cancels that, and 3 times. So 32 times 3. So instead of trying to figure out what 32 times 5 minus 32 times 3 is, just keep in mind it's 32 times 5 minus 3, so 2. So this is 30 over 32 times 2, which is going to reduce beautifully. We can cancel this 2 with that and make it 15. 15 over 32, square rooted. Totally fine to leave it right here before you do anything crazy, but this is a little bit cleaner.